Hello and welcome back. This is Arun, and today I'm going to walk you through another important big data concept and a tool to accomplish some of the big data day to day goals. Today we're going to look at ingesting real time and near real time data into HDFS and other Hadoop related storage mechanisms using a tool called Flume. Flume is very popular, and for the CCA 175 exam, I have heard mixed opinions regarding the inclusion of questions related to this topic during the exam. Majority of the people who posted their experiences of CCA 175 reported that they did not have any question related to real time or near real time asked during the exam. However, there were a few who reported seeing a maximum of one problem on Flume and also reported that the problem was straightforward and simple. My goal is to provide you a walkthrough of how to use Flume and also some problem scenarios to test your Flume skills. Flume provides ready-made configurations available for 95% of the real-time scenarios. All you need to understand is how to use some parameters and accomplish your goals. Given that there are several configurations, it is very challenging to memorize all Flume configurations. I am going to structure this video such that I can provide you what to memorize and what to find out during the exam. Remember, CCA 175 is open book but only provides you access to official documentation. Hence, let's look at the same content that is available during the exam to solve step 1 of the problem scenario. Click on the Flume user guide on the official Flume documentation. This is Flume version 1.6.x. This is what is provided to you in the Cloudera virtual machine, and this is what will be provided in the CCA 175 exam as of 24th May 2017. Cloudera typically matches the tool version available in their latest CDH with the tool version in the exam. As you can see in this picture, each Flume agent has a source, channel, and a sink. Source is the place where data is collected. Sources can be on multiple machines, for example, log files from a cluster of web servers. Sink is where the data needs to be sent. Channel is the mediator between source and the sink. There can be several types of sources, sinks, and channels, and I will show you how to use them via problem scenario steps. Let's look at step number 1. Step number 1 is about pulling data from Scoop and storing it on HDFS. We have performed this step several times during the earlier problem scenarios, but we need this step in order to prep our data. So let's try to pull this again from HDFS into a new folder called pre-work this time. So let's start writing the scoop command. So I'm going to start writing the scoop command using scoop import, and I would like to import the orders table based on the problem statement, and then provide the connection parameters using JDBC, MySQL, and I'm just constructing the URL over here. Quick Start Cloudera 3306 is a port number, and retail underscore DB is the database name. And then I'm going to use the username, which is retail underscore DBA, and password is Cloudera. As the problem statement suggests, you need to pull this data as an Avro data file, and I'm using number of mappers as 1 so that we can easily manage the data in one file rather than having 10 files and getting confused about that data. In exam, you can use whatever number of mappers you need, and the target directory is the pre-work directory as we have seen earlier. The scoop command finished, and the data must be pulled into the destination folder that we have requested the scoop to put the file in. So let's try to quickly inquire HDFS and see if we have the destination folder. So right now I am in a folder named Flume-Avro. This is my local folder, and from inside that local folder I'm saying Hadoop FS ls problem 7 / pre-work. Okay, so I can see an Avro file here. Now we will have to pull this Avro file into our local folder because the step 1 is asking you to configure an Avro source. Now Avro source collects Avro data, and you need to simulate that situation. That is why you need an Avro file. So let's use this Avro file a little later. Let's try to create a Flume configuration. All you need to do is create a config file with .config in the same folder that you are in and configure the source, channel, and sink. It is very difficult to remember each of these parameters that go into the configuration file. Hence, let's start by copying and pasting the sample set of parameters so that you understand the structure in which the configuration file needs to be created. So let's paste this here. As you can see, the sources, sinks, and channel are the important parts. A1 over here is the name of the agent. Let's try to name our agent as step 1. And let's try to change all occurrences of A1 into step 1 because step 1 is the name of the agent. Now, as you can see, Flume configuration file follows a certain hierarchy. Now, the first part of the string, which is the key in this properties file, is nothing but name of the agent. Let me try to replace all occurrences of A1 with step 1. Okay, now this is good. Next, we start configuring the sources, sinks, and channels. Let's try to name our source as Avro source because we are trying to use it use an Avro source just for the sake of naming convention, right? So if you look at the problem statement, you will see that the source over here is an Avro source, right? So let's try to name it as Avro hyphen source and the channel as JDBC channel and so on and so forth. Now you can name it anything you want, but if you name it as Avro source, you can easily recognize what kind of source it is just by using the naming convention. And then here I'm going to do JDBC channel. Okay, there are different types of channels, different types of sinks and sources, but here we are looking at an Avro source which is running at localhost on port number 1112. Now again, you don't remember how to configure this. For this, you need to go back to the Flume user guide and just go to the section which shows Avro source configuration, and you need to copy paste some stuff from there and configure it to the need based on what your problem is asking you to do. Okay, so let me find the Avro source first. Here it is. Okay, so let's click Avro source, and if you look at Avro source, the most important or the mandatory configurations are type, bind, and port. So let's try to do those. Okay, if you look at this, step 1.sources.avro source. So I have to replace R1 with Avro source. Okay, because look, this is a hierarchy as I mentioned. Step 1, I'm doing source configuration, and the source that I'm configuring is Avro source. You can have multiple sources and sinks within the same configuration and some multiple channels too. Okay, so let's try to change the source type as Avro, and then you need to the local host remains the same and the port number is 4 ones and a 2. Okay, now this finishes the Avro source configuration. Now we need to change the type of the channel. Okay, so let me try to copy the channel name first and replace K1 or C1 with the channel name. Okay, here the name of the channel is, we need to use JDBC channel, right? So let's find out where the JDBC channel configuration documentation is. Here it is, right? So only thing that that is mandatory over here is type, and all you need to do is to change the type to JDBC and remove the remaining two, because remaining two are not necessary and the problem is not asking you for any specific JDBC configuration scenarios. The next step is to configure the sink. Here, the sink that we have, the problem statement is asking you to do is an HDFS sink. So let me copy this line 3 or 4 times so that I can do multiple other configurations related to HDFS sync. Let me find out the user documentation related to HDFS sync so that I can understand what parameters are mandatory and what parameters are needed based on the problem statement. So at minimum, this requires type and HDFS path. So type needs to be HDFS. So let me change this to HDFS. And then the next parameter is HDFS.path. So let me change this to HDFS.path and provide the path of the sink. Now, if you look at what we have done earlier, if you see, this is the source. Okay, now pre-work had the file which was an Avro data file which we already copied into our local file system. So let's forget about it. Here we're talking about the sink. The sink is user Cloudera problem 7 sink. So let me copy this and paste it over here. Okay, just to make sure the directory exists. It does not, so let me create this directory so that the Flume configuration does not fail when we run the Flume agent little later during this video walkthrough. The sync is available. Let me just do a quick inquiry on HDFS regarding this sync. This is available, so let me just go back to the configuration file. Oh, I closed the configuration file by mistake. So let me retype all of this again and then resume this video so that we can start from where we left off earlier. Okay, just give me a couple of minutes. Fine, I retyped everything again. So if you look at this, we configured the sources channels and I went ahead and configured the HDFS sync as well. So if you look at the HDFS sync, I have the type, the path is the sync path, and because the file type is Avro, I'll have to put it as a data stream. The reason is it's an Avro file, it is not a general text file, so that is why I'm not putting a file format as a text. I'm just saying data stream, which means copy whatever is coming from the source as it is into the destination, because we want that to be same, right? So if you look at this, the file suffix needs to be .avro, so I need to configure the file suffix as .avro over here. And then because you're dealing with Avro, there is another additional parameter you need to take care of called as okay, so file type, I did this already, which is data stream, and then the serializer is the additional parameter I was talking about, which should be Avro underscore event. So we completed the configuration of source, channel, and sync. The last two lines tie the channel to the appropriate source and the sync. Okay, so now if you go back and look at the problem statement, now that this file is saved, this is our configuration file. Let's try to run this Flume agent. It may not be possible for you to remember all the configuration, so just remember Flume-ng 2 agent, and then when you run this, you will know what options Flume gives you out of the box in order to run your Flume agent. Obviously, the agent needs to have a name because you have configured something in the configuration file and you have to specify which agent you need to run, right? So let's try to do Flume-ng agent. Name is step 1, and then you need to provide the configuration file and the configuration folder. So here I'm going to say config, which will give the folder name. The dot means the current folder, and the conf file, which is the name of the file, which is f.config, right? Because we have used f.config while creating the Flume configuration earlier. Let's try to run this. Oh, there is a problem. Let me try to fix this problem again. I'll show you where it is. Okay, so the problem is because there is nothing called as 2 dashes or 2 hyphens config. Okay, because it's called conf, not config. So you need to be careful. Typos are not tolerated. So you need to copy paste instead of typing. And I've been telling you to do this, and I myself am typing over here. But in the exam, I would never type. I would copy paste so that there is no waste of time. Now, let this Flume agent launch. When the agent launches, it gives you a nice message saying the Avro source has started, and this is an indication that the corresponding channel, which is the JDBC channel, and the sync have been configured and started by Flume agent, and the agent is ready to collect data from the Avro source, which is running on a port number 11112. Now let me run the client. The client comes pre-packaged. There's no expectation for you to remember how to run the client. You will get this command during the exam as well, but you need to understand where to get the source Avro data, and this is the same data file that we have pulled from HDFS earlier. So I'm feeding this Avro data file to my Avro client so that the client can transmit this data via the channel into the sync. Now, as you can see, the client is running, and on the server side, which is the Flume agent, you can see some activity happening, right? Now, this activity is pulling data that is available in the client and pushing this data into the sync. As you can see, the client has finished execution, but there is some activity going on the server side, which clearly indicates asynchronous processing. which is what Flume is famous for. Now let's try to inquire HDFS, the problem 7 sync folder, to see how many files have been created so far. Now, as you can see the pattern, there are multiple Avro files and one temp file, which means Flume kind of accumulates all the data into the temp file until a certain point before it creates one Avro data file. As you can see, this is still running, and let's try to wait for this agent to finish its activity and then inquire HDFS again to see if there is any temp file is left. Okay, as you can see here, the writer callback called, which means all of the agent activity is complete for the client that we ran before. And when you do an HDFS ls, you'll see only Avro files and there are no temp files, which means all the agent activity is completed as of now. Now this concludes step number 1 of problem number 7. Let's look at step number 2 next. Step number 2 is another Flume problem. Now this problem is providing you with 3 pre-packaged jobs called start logs, stop logs, and tail logs. These 3 jobs are available in your CDH environment, and these will be available in your certification environment as well. Now let's try to use these jobs and do something. Before that, let me try to confirm if these jobs actually exist. So let me launch a terminal, and then let me check if a folder like this exists, because this folder is where the logs are stored when those jobs are executed. Now this is not your problem solution, this is pre-existing condition. You're just validating if this condition is true or not. Now all you need to do is do a tail on those logs to see if the last line of the log is 537.77.4. Now let's try to start logs, clear this first, and then let me start logs. Okay, as it is mentioned over here, I'm just confirming, guys. Again, this is not a solution to the problem, this is confirmation of pre-steps. So when I run this start logs as a daemon thread in the background, it continuously generates some logs. As you can see, the last line is 537 now. And then when I do the tail again, the last line changed, which means the log file is getting appended continuously because we are running start underscore logs in the background. Let's stop the logs now, and let's try to do a tail again to confirm that the log generation has stopped. Yes, the log generation has stopped, which means the precondition for our problem is valid. We can leverage a bunch of these prepackaged jobs in order to go ahead and solve the problem that we have. Let me create a directory name flume-logs, and then do a cd into that directory. Now I am in flume-logs, so let me start creating a Flume configuration file by doing gedit f.config. Oops. Let me close this. Let me close this first, and then let me say gedit f.config. Now, as I mentioned earlier, it is very difficult to remember. Now, I deliberately closed the browser window so that I can show you how to get there. Okay, so CCA 175, just search for it in the browser. I don't think it is using the default Google engine, so let me try to close this and then try to use Google instead. Okay, so let me use Google and search for CCA 175 exam, so that you can access the same documentation that is available during the exam. So you need to get used to that. You cannot be accessing some of the documentation and still expect that you don't waste time during the exam. For you to optimally use the time, you should go through the same documentation during your practice that is available during your exam. And whatever is available during the exam can be launched from the Cloudera website only. So Flume user guide, and then from here just copy the sample Flume configuration just like we did last time, and then we will modify this configuration to suit our problem need. So here also we have source, sink, and channel. I'm not going to rename any of these. I'm directly going to jump into how to solve this problem. The first step is to configure the source. Here the source is not the spooling directory source, that has a different purpose. We need to look at the exec source because you want to execute a command called tail, and the output of the tail command should be pushed into HDFS. So the command here, let me copy this and let me put it here as command. Okay, r1.command, and then let me type the command. All I need to type is tail -f. -f is fetching the tail every time there is an update to the log. It fetches the new tail, which means the delta in an incremental fashion. That is why I'm using -f option of that log. So that is my source. So when I do a tail on that source continuously, whatever incremental chunks of data that I get from that command will be pushed into HDFS based on the configuration we're going to do now. So the next step of the configuration is to use a channel that is non-durable. Non-durable means in-memory channel. So that is why I need to provide a value called memory to indicate that I need to use in-memory channel. Next, there are a couple of configurations. First is to use the capacity as 1000, which is already pre-configured, and then use the transaction capacity as 200, which means after every 200 messages, data in the channel will be committed into the sink. Now let's try to configure our sink, which is HDFS sink. So let me search for the user documentation for configuring HDFS sink. Take this, and then as we have done earlier too, the two parameters are type and HDFS path, which are bare minimum. So let me try to name the type as HDFS, which I've done, and then do some copy paste activity in order to create the next parameter or the next key value pair, which is HDFS path, and the path should be step number 2, which is the folder which we need to create on HDFS. We're going to do that a little later. So let me just copy this folder name here for now and then configure the rest of the parameters. If you see, we need to have a file suffix so that it is neatly distinguishable, and we can have a .log extension to our file. So I'm using HDFS file size. So feel free to use whatever configuration you think makes sense in order to accomplish your problem accurately. Accuracy is what Cloudera is looking from you, so be very careful when you choose a configuration. Do not over configure and lose marks during the exam. So next is the write format. So I want to use a text format, obviously, because my log file is a text file. So I'm going to use write format as text file, doing the same exact exercise as before. Copy paste, do not type and mess around. So let me do text here, and the next configuration is, if you remember, we need to have something called as file type, because by default it saves as sequence file, but you want to save the file as it is. So let's try to store it as a data stream. Now when I say as it is, I meant to say whatever is coming from the source should be put in the destination as it is, as a data stream. So let me put it as data stream. Now this finishes the configuration of the sink, and this also finishes configuration of the source and channel. And because we copied the entire set, it is already tying the source and channel to the source and sink to the agent, and agent is tied to the channel already. So let me try to copy this sync folder and create this sync folder in HDFS using mkdir command. Now paste this. So this should be created on HDFS. Now that it is available, let me run the Flume agent. All you need to do is say flume-ng, as I mentioned, agent, and then name is K1 or A1. Let me confirm that. So we copied the agent configuration from a certain location. If you go back to that location, you will know it. Alternately, you can open the Flume config file and understand the name of the agent. Instead, I'm going to just go here. Yes, A1. A1 is the name of the agent. So let me say A1 here, and then conf is dot, which is the current directory, and conf file is f.config. Let me run this Flume agent real quick. Okay, as you can see, the Flume agent started. It did not it did not start yet, but now it started. As you can see, R1 started, and then rest of it, and it already started putting some log file, because by default there was some data in the log file. That data has been pushed to HDFS, and when we look into Hadoop, you will see that the log file is already pushed into HDFS, which is the current state of the log file. Okay, if you look at this, you see log, and temp is temporarily it stores data there, and then it kind of rolls that into a .log file every time it exceeds a certain transaction capacity or a file size. Now let's try to look at uh, the tail of the log. You can see the tail is 537.36, the last line, the last words of the line. I'm doing the tail again just to make sure that there is no activity happening. As you can see, there is no activity happening over there. Now let me do start underscore logs. Okay, let me put these windows side by side, and then let me say start underscore logs so that I can start the job. Now, because the job is started, on the left side window, you will see some activity happening, which means every time the log file is updated using the start underscore logs, a tail command is issued. The incremental data is taken into the channel, and the channel is pushing that incremental data into HDFS. So this activity is happening in front of you right now. All you need to do is to inquire HDFS by using ls command to see if more log files are created. As you can see, earlier there was only one log file, now you can see multiple log files. Let's top the logs as the program, as the problem suggested, and then let's look into the HDFS folder again just to make sure that no new log files are created. Now this completes step number 2. I have provided the solution to this problem in my blog as well. As you can see, you scroll down, all the steps are neatly captured, but the video shows you a more detailed view of the steps rather than the steps alone. I hope you enjoyed the video, and stay tuned for more videos in this video series. Bye.